All right, let's take a look at the questions on page 235. We did number 14 together in class, so let's take a look at number 15. A mechanic exerts a force of 45 newtons to raise the hood of a car 2.8 meters. So he's putting a force on it of 45 newtons upward, and he's raising the hood of the car, so delta D is also upward, 2.8 meters. Okay, and so the question says, after checking the engine, the mechanic lowers the hood. Find the amount of work done by the mechanic on the hood during each of the two motions. So for the way up, work is equal to F delta D cos theta. It tells us the F, it's 45 newtons. The delta D is 2.8 meters, and they're both going up, so it's cos of 0. Oops, that really is a 0, not a theta. And when you do this, you should get 126 joules. Okay, so now when he lowers it, his force is still going up, but now the car's hood is going down. So everything will be the same except the angle. So it'll be delta D cos theta, and so W will equal 45 newtons times 2.8 meters times the cos of 180. And the cos of 180 is negative 1, and so you get negative 126 joules, where the negative means losing energy. Okay? That is number 15. Number 16 says a father is pushing a baby carriage down the street. Find the total amount of work done by the father on the baby carriage if he applies 172 Newton force at an angle of 47 degrees. So he's pushing the carriage, so his force is going to be this way, and it tells us it's 172 newtons, and it tells us the angle here is 47 degrees. Okay, and so this is the baby carriage, and the baby carriage, the delta D is going in this direction, and it tells us he's pushing it 16 meters. Okay, so what's the angle between the F and the delta D? It's the 47 degrees. So W equals F delta D cos theta. So W equals 172 newtons times 16 meters times the cos of 47. So look at that. For the first time, it's not 0, 90, or 180. It's actually 47. And when you do this, you should get 1,876.86 joules. Okay? Number 17. While shopping for her weekly groceries, a woman does 2,690 joules of work, so that's your W, to push her shopping cart 23 meters, delta D, 23 meters, down an aisle. Find the magnitude of the force she exerts if she's pushing the cart at an angle of 32 degrees. So theta is 32 degrees. So it's going to look like this picture up top, except this time the angle is 32. W is equal to F delta D cos theta, and this time you're looking for F. So it's equal to W over delta D cos theta. So 2690 joules divided by 23 meters times the cos of 32. And when you do this, you should get an F of 137 point, it might be 9. I'm not sure if there's another digit there. I can't see. Newtons. Okay, that's number 17. Number 18 says, a farmer pushes a wheelbarrow with an applied force of 124 newtons. So 124 newtons. If the farmer does 7,314 joules of work, so that's your W, on the wheelbarrow while pushing it at a horizontal distance of 77 meters, that's your delta D. Ooh, this time they want you to find the angle. Okay, so again, here's the thing. He's pushing it with a force this way. delta D is going this way. You're looking for the angle between them. So W equals F delta D cos theta. So cos theta equals W over F delta D. So your 7,314 joules divided by your 124 newtons times your 77 meters. When you do this, you're going to get cos theta to equal 0.766, and then you do second function cos on your calculator, and you find theta to equal something really close to 40 degrees. Okay? Now, let's flip backwards to page 229, where you had to find the areas under those curves. Okay, so I asked you to do number 11, and 11A should be pretty straightforward. The height, the F is 15, and the length is 12, and so you just do F delta D, 15 newtons times 12 meters, and you should get the work to be 180 joules. That's for A. For B, there's two different triangles there, right? They kind of look like, when I see this, I always think it looks like a dolphin or a shark fin. Okay, so this little tiny guy has a base of 15 meters, and he has a height of 2 newtons. So 2 times 15 is 30, take half of it, 15 joules. The bigger one has a base of 25 meters, and it has a height of 4 newtons. So 4 times 25 is 100, take half of it is 50, add these together, and you should get, whoops, I wrote newtons and it's joules. You should get 65 joules. Okay, C. C is two triangles, one above and one below. And the base for the one above is 2 meters, and the height is 5 newtons, so 2 times 5 is 10. Take half of it, it'll be 5 joules. Looking at the one below, its base is also 2 meters. Its height is minus 5, so 2 times minus 5 is minus 10. Take half of it, and you get negative 5 joules. So what is the net work done? 5 joules minus 5 joules, it will be 0 joules. Okay, so the next one, and I would never be this mean on a test, okay? But the next one is this cool little diagram. Now, the easiest way, I think, of doing this, no, you can't just draw a straight line and estimate. But what you can do is you can say, okay, if I look at this little point down here, can't even find it, there it is, this little point, it's just a tiny little part of the square. And then if I look at this one up here, it's just missing a tiny little part. So those two together will give me one whole square, and then I could count the squares. This little piece will add to that one, so now I'll have 2 whole lines. This piece will add to that one. I'll have 3 whole lines, and then I just keep estimating. I add the ones along the line up, and then count the total number of squares. And if you do that, you get about 48 squares. And then if you look, each square, it has a base of 1 and a height of 5. So 1 times 5 will be 5 joules. So you're going to end up with a total area, as soon as I find my book, a total area that will be 48 squares times a base of 1 meter times a height of 5 newtons. And so you should end up with an area of 48 times 5. So it'll be roughly equal to 240 joules. Okay, but again, I would not be that mean to you on a test. I wouldn't give you one that had those weird curves. All right, you have one more page to do. It's over on page 266, and it's the power questions. All right, so 266, and there's just 3 of them. The first one says, a mover pushes a 25.5 kilogram box with a force of 85 newtons. Okay, so number 40.